Testing, testing, 1, 2, 3, testing, testing. So how's everybody in chat today? Yes. Yes, that is the problem with video games. Is it good, the new Animal Crossing? Yeah. I never really got into Animal Crossing personally. It always seemed a bit, like, a little too cutesy and a little bit too aimed at a younger audience, and I always took myself very seriously as a child, so, you know, yeah. Also, like, the first one came out on the GameCube, and at that point I was, like, old enough to not really be interested in that category of game anymore anyway, so I don't really have the nostalgia for it either. Well, anyway, enough about Animal Crossing. Yep. We should get started, even though we only have 19 people watching. Thank you very much to those loyal 19 people who are sticking it through to the end. I appreciate it. I really do. I know that probably a lot of people realize that they can watch these in post now and are probably doing that instead. I can't go outside in real life, at least I can fish and invite friends onto my private island. Oh, it's got multiplayer now. That's cool. I know all about Animal Crossing. I know I think that's Animal Crossing. Apparently you have to catch tarantulas. Yes, not exclusively though. My understanding is that you also catch a wide variety of insects and fish and fruit and things that are in the ground. And that it's mainly a collectathon game, but without the platforming. But anyway, yeah, at any rate, we should probably have our lecture today. It's a nice, fluffy topic. It's a pleasant one. There's interesting things to look at. We're going to be talking about graphs. So, before we get there, I'd just like to update you guys on the recent happenings with respect to the announcements for the course. I have decided that before we moved to the live stream format, we, of course, didn't have lectures on days when we had tests because we had the tests during lecture time. So it makes all kinds of sense to me for us to not have a lecture on the day when we're having a test. So the lectures for Tuesdays of next week will not happen. I just wanted to double check. I only submitted my A8 on Jupyter Hub and not on Avenue. Is that okay? Yes, that is okay. You have done well. It's a you can submit here or there situation. In terms of Boolean operators, it would be an OR operator. So make sure you have submitted to either Jupyter Hub or Avenue. Both is not necessary. Neither is probably not going to result in very many marks. So yes, yes. Still, you can still submit through Jupyter Hub. Now that they've expanded the VPN, it is perhaps a lot easier to get at it. The policy was put in place before they had expanded the VPN capacity, so we had to take steps to make sure you guys could still submit assignments. But since we now have the ability to submit more or less reliably through VPN again, possibly there's, let's see. I can tell you right now, I had 23 people who submitted assignments through Avenue rather than through Jupyter Hub, which, considering there are 270, 80 some odd people in the course, that's a reasonably small fraction. So I imagine most people went through the VPN. But anyway, so we won't have any lecture live streams next Tuesday because you should be working on your test. And we should, we're also, there's one, like the T3 tutorial section, which occurs on Tuesday. That's going to be moved to some other point in the week, hopefully onto Monday, but we'll see. Sort of depends on the TA's schedule. So that sort of clears the docket for Tuesday, so you can have as much of that day as you could possibly. Well, at least I will release you of any obligations to this course while you are writing, fulfilling other obligations to this course. Could you cover the topics on the test days? Maybe you could have optional lecture on databases or GET post requests, just for those who are interested. Well, the lectures are going to stay pretty close to the material that I have to present to you. That being said, there is a set of lecture slides on databases, and contrary to my impression of things when I set the course up in January, this particular set of lecture slides on graphs could probably be cracked off in one single session. So probably we will get to the database stuff, yes. But the question is more along the lines of what is testable. Primarily, three things. There are three major topics for this upcoming test. We've got classes. Obviously, we spent 2 weeks on classes. There is I/O, so file reading and writing. That is definitely in the territory. And there is testing and exceptions, which was, I believe it was in the zone for the last test as well, but it wasn't actually tested on the last test, so I probably going to carry forward a certain amount of material onto this test. So there you go. That's your me telling you what's on the test. Make sure you're comfortable with inheritance. That's my hint, my patented Mr. Moore gives a hint on the test moment. There you go. Except now the entire internet can see it. Anyway. So yeah. So there's one other thing to be talking about with respect to the test schedule, and I don't know if anybody listening to, whether this applies to anybody who's listening at the moment, but for those of you who have Student Accessibility Center, or whatever their acronym stands for, the people who have accommodations for this course, those of you who have the sort of pre-authorized accommodations where you get a certain amount of extra time to write a test based on the length of the test, we are going to be I was sort of originally on the fence as to whether that's applicable in a situation where you have a 24-hour test, whether, 24 hours is more than enough time. I certainly didn't write the test with the express purpose of it taking you 24 hours to write it. That I did not do that, so you can perhaps stand at ease with respect to that particular point. But I have thought about this, and I think that the thing to do is to proceed along the basis of giving those accommodations proportionally to the length of the test, given that the test is 24 hours. So for those of you, and as you may remember from last week, the test starts at 9 o'clock in the morning and ends at 9 o'clock in the morning the next day with zero margin for late submissions, folks. Zero margins for late submissions. Because, I apparently have to say that. So, with respect to people who have accommodations, if you have X number of minutes extra per hour, then that will be honored with respect to a 24-hour test. So if you have the example given here, an extra 30 minutes per hour testing, that's an extra 50%, so that would be 12 additional hours to write the test with respect to test 3, and also this will apply to the final. I have a question. Hey, so I noticed there was a live lecture on Friday. I thought we didn't have class then. No, you don't, but the other class does. Yes, I haven't actually, for whatever reason, I might have, I suppose, at the beginning of all this, sort of consolidated the two sections into one live stream, but then whose schedule are you going to go with, right? Yeah. If other professors are doing the same thing and live streaming at specific times of day, I suppose it makes less difference because you can access the lectures after they've been live streamed, but yeah, so that's the C1 section. You're absolutely welcome to listen to the C1 section lectures if you really want to. I will be covering pretty much precisely the same material. The only difference will be what questions are asked. Also, the C1 section likes to get a little bit more gamer-esque in the chat, but they are entitled. I in the other section, I'm pretty sure it's the other section where I've got a guy who is LeBron James, and it's just LeBron James in the chat, and he's, well, the last time I was programming when I was playing basketball, etc. stuff like that. But anyway, ooh, we're up to 29 people. Excellent. So anyway, that's the changes with respect to next week. Hopefully the test will not be too bad with respect to people thinking I'm being mean intentionally and stuff like that. Anyway, I'm not. Let's talk. Let's continue on with our lecture material for today, shall we? So, Last time we had left off, we had talked about some very preliminary items with respect to the new unit on graphs and plotting. So, just opening it up. I had it downloaded. I don't know. Oh, is it here? It's there. Excellent. There we go. So, oh, for God's sake. There we go. Ha. So, just to review quickly, we have there are a number of different libraries that you can use for Python to perform the types of things that we are going to perform. They all have various advantages and disadvantages. A good general purpose one is PyPlot. It is sort of well supported. The syntax for it is reasonably basic and should be easy enough for anybody who's been following the course along so far. So we will be showing how to do some stuff in matplotlib using PyPlot. In order to install matplotlib, the easiest way to do that is to just install the Anaconda package, which includes all of these types of libraries, not just matplotlib, but a large number of additional libraries for scientific computation and stuff like that. If you're using a local Jupyter Hub instance, as I am in this particular instance, since I shudder to think what the result of me trying to put my live stream data stream through the VPN would be. All of the matplotlib, etc., all of the scientific libraries are included in the. You don't have to manually link them to the Jupyter instance that comes with Anaconda. It'll come there automatically. However, should you ever need to install it manually, you would need to use one of these commands, and if you are using Linux, you will probably know what sudo means by that point. So, these commands are actually not necessary, as you can see, with respect to a Jupyter Hub instance. You don't actually need the magic commands. All you have to do is use the import line, and that will import the matplot. It displays it reasonably. If you want the interactive stuff, though, you have to use nbag. So, this first example, as you can see, I've copied the code straight from our slide into a Jupyter instance. So the way that this works, you need a list of x values and a list of y values, and it plots them as if it were a scatter plot graph, but with a line connecting the values. This is the most default setting for matplot or PyPlot. So in order to, actually, you know what? Let me increase the magnification here a little bit. There we go. So in order to create the plot, there's a distinction between creating the plot and showing the plot. So you create the plot by calling a bunch of methods as applied to the PyPlot object that you have imported from matplotlib. So in order to plot the x and y data, you have to call plot, give it the x data, give it the y data. Of course, x data will precede y data. This is a naming convention. It's not strictly enforced. So if you wanted to, you could reverse x and y, and it would deal with the x data as if it were the y data as if it were x data, and the x data as if it were y data. You can see although the appearance of the plot did not change, the values along the sides and bottom did, as you can see. So, this is all good. So, this is good. But, you may be asking, how on earth am I expected to plot a function? Well, I'm so glad you asked. The manner in which we are plotting a function here is derived from the idea of generating a series of scatter plot points rather than graphing symbolically. So it's not really first year material, but there are many scientific computation, mathematical computation software packages out there which allow you to do simplification of algebraic expressions, these types of things, which are based on symbolic math rather than everything having to have a defined concrete value, which is very similar to the variables that we have been dealing with so far. That's the distinction that the software packages usually make. Variables, as you have been using them in mathematics up to the point where you learned about the nomenclature in programming, these are considered symbolic variables within the context of computing. There are a large number of symbolic packages that you can use, and I'm sure that Python has one. It's nowhere in these slides, and I don't have the library name in front of me, but I can assure you that it exists. But that's not what we're going to be doing here. We're going to be generating a range of x values, calculating the y values from those x values, and then plotting that. So we first, of course, need our x values. So we'll call it x, and we will make it a range object from -100 to 100. Next, we will get our y values. This is a syntax which I'm pretty sure you guys haven't seen yet. It's called list comprehension in x values, or x. Just have to make sure the names don't conflict. So the syntax here, you see we're using for and we're using in. So for x0 in x, this is the same syntax as you would use to create a for loop. However, in this particular instance, it's very similar to the following syntax for if statements. B equals 3 if x is greater than 2, else 4, right? You remember that from earlier in the course. It's very similar to that, but with generating a number of values within a list. If you want something that is expressed in more code, a perhaps more understandable code format, it's exactly equivalent to the following. So for x0 in x, well, you would first declare y as being an empty list. Y is equal to y plus x0 raised to the second power. It's just taking these three lines and compacting it into one line, really. But are there any questions about that? I know that's something we haven't seen yet before. While you're perhaps writing some questions, I'll write out the rest of this code. PyPlot.plot x and y, and PyPlot.show. There we go. Execute that function, and you can see we have this very nice polynomial function. Pardon me, I almost called it an exponential. Wouldn't that have been hilarious, the internet? So you can see we have this nice swoopy parabolic curve. However, you may notice we are in fact plotting things on a pretty massive scale. So the question is, what happens if we try to reduce this range to something a little more close to home? Say we wanted to plot something on the range -5 to 5. you can see that we have this jagged disjointness going on. And you might also notice, if you're observant, that the points of inflection in this curve, which is looking a lot less curvy, are at the at the whole number intervals. So what is happening here is that x is a integer rather than a floating point number. In order to smooth out this curve, we're going to have to generate a number, a reasonable number of the points between, for example, 0 and 1, right? So, unfortunately, Python does not come with a range function for continuous functions. However, so this slide 8 is saying those things that I just said. We have this new function at the top here, which has been provided in the slide after this one, actually, a floating point friendly range function called frange, or frange, if you will. This is a very simple function. It complies to the same conventions as regular range. It just uses floating point numbers. You've got a stop, a step, and a number of decimal places to keep, which is an optional parameter. So, and it also generates everything as a list object rather than a range object. L.append round x to rounding it to the number of places. You start at whatever the start is, and as long as x.round places is less than the stopping point, then you're good, and you're stepping by the step. So, really reasonably straightforward way of going about it. So let's see what happens when we change our range to an f-range and make our stepping point 0.01, something like that. Oh, we got a name error. Frange. Oh, I need to run the box. Boink. There we go. Hopefully, there we go. Now see how nice and smooth this function is. It's very, very smooth. It's amazing. Smooth like butter melting over freshly steamed peas, like in that one commercial. Anyway, I don't know if any of you actually relate to commercial culture. My impression is that young people generally do not watch television. I also do not watch television, largely. But anyway, so this is fine. This is good. If you want to plot other functions, it's really quite simple. All you have to do is replace this term here with whatever function it is that you wish to plot. So if, for example, you want to do math.sin x, do we need to import math? We need to import math. Good golly. Type error. Really? Oh, yes. I need to. There we go. So you can see that plots us a nice sine wave. And, if you want to do something interesting, let's do it for the range from 1 to 10, right? And let's make the function somewhat more complicated. Maybe increase the frequency. Cool, right? Ooh, increase the frequency even more. Haha, there you go. So yeah, you can plot pretty much any function you can express. But yeah, Anyway, so up to this point, we have been talking about all of these plots without really modifying the default appearance or the default type of graph that we're working with here. So with respect to the types of graphs, the way to invoke a different type of graph is to replace the plot term with some other method corresponding to the type of graph that you expect to see. Let's change this to something reasonable again. Let's just make it a regular sine wave. Let's leave the exponential decay. There we go. So, if you would like to have a scatter plot, you just write scatter instead of plot. And you can see that we have a lot of points in this particular one. So, let's reduce the number. Well, we can reduce it even a bit further. There you go. The difference from a structural perspective between the scatter plot and the regular plot is really quite minimal. In the scatter plot, there is essentially the only difference is that the scatter plot, the regular plot draws lines between the points and expects there to be a a linearity to the data. With the scatter plot, of course, you can plot what you might like fields of dots in the manner, and you can do regression and the type of data that you would do a regression analysis on. You can use scatter for that sort of thing, but you can also plot a scatter plot of the results of a function calculation, as you might expect to be able to. So this is good. So let's talk CSV files. All of you hopefully remember CSV files from 3 weeks ago. I think we were talking about them. So just to remind you, in case you forgot, CSV stands for comma separated value. CSV files are a plain text spreadsheet format. No formulas, no formatting, no nothing. It's just numbers separated by commas. However, it's a very nice and useful way of transferring data between applications because it does not assume any formatting. So, our approach for this is to read the data from the CSV file using the approaches that we discussed in the previous lecture, i.e. using the CSV library. Then we want to construct the x and y values by iterating through the rows of the CSV file. There are some libraries that can do this more or less automatically, including numpy.loadText and pandas. However, you can also load data from a network file using the approach used in the previous lectures. We used JSON files, not CSV, but you can apply the same methodology to a CSV basically in the same manner. So, in order to plot from a CSV file, first of all, we want to import, not improt, we want to import CSV, because that's going to be useful. We want to, of course, open up our CSV file with the file handle. So with open sample.csv, putting it in read mode, of course, as file handle. Rows is equal to CSV reader file handle. There we go. X is empty list, Y is also an empty list, and for row, in rows, X dot append row 0. So for every row, we take the first element in that row and append it to X, and we take the second element and append it to Y. Remember, everything is 0 indexed. If you learn nothing else from my course, learn that it's 0 indexed. I've got like weird doubling of my tabbing going on, but hopefully it'll still work. So, PyPlot dot scatter x and y. PyPlot dot show. And there you go. And as you can see, well, that's interesting. Well, this is interesting, because that's not exactly what's supposed to happen, is it? So, if you may notice, we have a mismatch between our plot as generated by the code as per the slide, and the plot as generated by this code, which is hypothetically exactly the same code. Very strange. Notice how it's taken the value 2 and put it up above 6 rather than... Okay, let's try plot. Does plot do the same thing? Good lord, what is going on? Very strange. Huh. Is it the tabbing? Can't possibly be the tabbing. Yep, I don't know how to explain it. It's very strange. It's very, very strange. Yeah, it's... Okay. I apologize for this, but I have to find out what the problem is with my plot. Well, anyway, I don't know what caused that, but oh, wait, did I make a typo? Oh! Yeah. No, you're right. It's because it's in Okay. Yeah, no, it's probably because they're being interpreted as strings. Yes. Yes, yes, queen. Dun 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 dun. Okay, so credit for that one goes to Gregosta. Thank you very much. You are a gentleman and a scholar. Yes, so it was... So that's an important lesson. Interesting how that code in the slide doesn't seem to need string conversion. So when you read stuff in from a CSV file, and this is interesting, this is a good teaching moment. When you read stuff in from a CSV file, its automatic default representation is going to be a string, even if it's a number. So if you have to do anything in order to do anything useful with it, if it's an integer, you have to convert it to an integer. You have to like you have to make sure with CSV files that you are performing the correct type conversion, type interpretation in order to actually use it properly. And if you don't, you might get unexpected results, which is what just happened with us. So there you go. We didn't break math. We were just being stupid as usual. There we go. Fantastic. PogChamp. I don't know what that means. So, good. So let's talk about a different CSV file now, one that has the header row and can be read using dict reader rather than the regular CSV reader. So import CSV with open sample2 CSV, reading R as file handle, rows is equal to csv.dict reader file handle. X is an empty list. Y is also an empty list. For rows in, just row in, rin in rows. X dot append integer conversion of row dot day and y dot append. So with close, you should actually always look at the data and see what data format we're going for here. So if you take a look at the actual values for close, you can notice there is a definite decimal point in those, which make this floating point values rather than integer values. So let us perform the appropriate conversion. Float row close. And again, don't worry about the single versus double quotes. In Python, it does not matter. PyPlot, plot, dot, scatter. X and Y, PyPlot, dot, show. Habam! There we go. And this data is performing in the manner we would expect. So, good. If there are any questions about that type of stuff, please put it in the chat now. So there are a number of additional things that you can do in order to enhance your plot. You notice that this is a very, very basic plot, and that in grade school they were hopefully always on your butts about labeling your axes and making sure that you have a name for your data that makes sense and adding legends and all of this stuff, because who knows what this graph means? It's impossible to know. So let's add some things. Let's add a title. PyPlot.title. That will be a string. Closing prices by day. It's one of those most unimaginative possible titles for a graph, which is just saying the X thing or the Y thing by the X thing. So we can also add X and Y labels to our X and Y axes. So X label is day of week. PyPlot dot Y label closing price. We can add a legend, PyPlot dot legend. This is a list of labels, or a list, rather than just having a single string, we actually have a list of strings. Each string in the list will be a label for one of the sets of data. So in this case, we'll call it DJ. And then, of course, we can add a grid if you like grid lines. If grid lines are your thing, then we can enable them. And there you go. We have a very different appearance now. Very cool. There are many other options as well. Things like colors, line styles, marker styles, all of the stuff that you would expect from the graphing functions in something like Microsoft Excel, stuff like that. However, there are too many to go through now, so if you would like to have more options than the ones that we have discussed in lecture, as always, I 100,000% encourage you to go consult the stuff on the python.org documentation. Or in this particular case, you would probably want to go to this website, which is the actual matplotlib site. They will have sometimes, like when you want the documentation on a specific website, the people who make that, or website, sorry, when you want documentation on a specific library, the people who write the library will often already have documentation on their web, like they'll have a website somewhere, so you should go find that rather than relying on the Python website, although the Python website will probably link to their website somewhere. So, as we just demonstrated, you can use all of these options. You can also modify the axes, like how large the axis, how far it goes up, in which directions. You don't actually have to put all of this stuff prior to the actual invocation of adding the data. You can configure it. You can have the configuration commands before and after the adding of the data to the chart. You just have to have them before showing it. Question: does the parameter for PyPlot axis have to be in list format? Probably it also accepts a tuple. Let's see. Let us... Oh, it's been doing that lately. So, probably just my video card crashing, no cause for alarm. PyPlot.axis. Let's try it in tuple format. 170,100. Will this work? Yes, in exactly the same manner. So, list format or tuple format, but actually, you know what? It might even work without this. Let's try it. Nope. You need to be inside of some sort of data structure. There you go. Lists and tuples are largely interchangeable. So, we can also have histogram plots. Basically, most of the rest of the slides in this are demonstrating a few different types of plots. So, being, for once, true to my word, we are actually going to get through all these today. So, in order to plot a histogram, you just call hist rather than scatter. And then you can generate a histogram. Notice that we're not using scatter or plot, we're using hist for histogram. If you want a bar graph, then you use a bar instead of all of the other things that we've discussed so far. Let me just copy that over, and you can see it working. There's a bar graph, and if you want horizontal bars, you do bar H. There you go. Object of 3 artists. There you go. PyPlots, pie charts, are also a thing. In the case of pie charts, you similarly to how you use X and Y data for scatter plots, in the case of a pie chart, you need data and categories. So, when we run that, there you go. So it says looks weird without this. Let's see what it looks like without it. Oh yeah, it's kind of fuzzy, right? Maybe? I don't know. Personally, I can't tell the difference, but there you go. So there you go. That's how to do a pie chart. You can, of course, plot multiple data sets. On a regular chart, you just separate them with a empty character, and then you can add more of these. So, for example, going back to our example for the exponential decay of the sine wave, we could have that as y1, and we can make a y2, which does not have the exponential decay in amplitude, and we can call that y2. And so we can plot y1, comma, there we go, empty string, x, y2, and we have a problem, raised value error. Well, maybe we don't need this. Okay. You know what? I should just stop trying to do fancy stuff. I think that's the problem. Invalid syntax. Oh, yeah, that would be invalid syntax. Maybe. This is just going out on a limb. Maybe this will work, maybe it won't. Aha! There you go. That's the way to do her, folks. Just use multiple invocations of scatter. That is by far the easiest thing to get working, apparently. Good. So, if you want to plot things with time formats, this is another thing that we haven't really talked about yet, but there is actually a DateTime library that you can import, which will allow you to have access to proper string formatting of dates and times. So, for example, if you want to create 3 date objects, you can use those in place of x values, and you can see that, you have sort of reasonably nice formatting for dates along your axes, which will be configurable. In order to save a plot, because, this is all fine, but fundamentally, if you have to perform a weird screen capture operation in order to actually save your plot, that might be suboptimal. So there is a pyplot.savefig, which will create the file name that you give it, which is fine. So, for example, and I know I'm hitting the time, but just give me 2 seconds. pyplot.savefig example.png. All right. So, in theory, we should be able to go to here and there you go. Example.png. I don't think that Jupyter knows how to handle those. So we're just gonna open it and it's blank. Okay. Well, anyway, there might be If using multiple instances of scatter plots, both datasets, how do you? Oh, you would use two separate PyPlots. I would recommend doing that in. So sorry guys, I will read this question because it's a good question. If using multiple instances of scatter plots on datasets, on both datasets on the same figure, how would you plot two separate datasets on two separate figures? Well, you would have to have a different PyPlot object, right? So the way that this is working underneath the hood, it's actually in the same manner as we have been doing classes so far, right? PyPlot is your instantiation of the matplotlib class, right? So all of these methods that you're calling are setting parameters inside of a class, and then when you ask it to show it, it takes care of it. Just you're invoking a method which plots it. So in order to have a separate chart that you're working on, you would need a separate chart object, right? So you'd have PyPlot and PyPlot2. The way to do that, I would imagine, is rather than importing matplotlib.pyplot as PyPlot, just import matplotlib and then manually instantiate two instances of a PyPlot object, and then you can use them separately. If that makes sense. Yes. So anyway, saving files is supposed to work somehow, which probably works somehow in some way. And there is lots and lots. This is the last slide. Sorry if we're going a little bit over. There are lots and lots of different types of plots that you can have. These are just some examples. You can have polar, 3D, subplots, adding text and arrows, error bars, customized plots. You can do anything you can think of. It's very cool. But yes. Anyway, so that's plots. We did actually manage to get through pretty much that entire lecture in one session, which is phenomenal. It means we'll have some time to talk about databases this semester, which is fantastic because databases are also cool. Databases, and also we'll talk about machine learning to a little bit. We're not going to get like heavy and that's like a really big topic, but anyway, I'll stay online for a few more minutes in case anybody has any questions. But aside from that, thank you very much for your time and attention, folks. Bah! There you go. You just have to not plot it. There you go. So I guess plotting it might also clear all of the information that's been accumulated inside of the class. That's an interesting. So that might be another answer to that last question about how do you plot two separate pieces of data. So let us run a little bit of an experiment. Yeah, there you go. So there's your answer. Every time that you invoke pyplot.show, it's actually wiping out all of the information inside of pyplot. So if you want to have multiple plots. All you have to do is have multiple segments of code which generate those plots that are separated. You don't actually have to instantiate multiple objects, although I think that would also work. Anyway, I can see that there aren't any questions, so I will catch you all tomorrow. Take her easy, folks.